Usually for perfect competition questions, it's going to assume a constant cost industry, which remember means that all of our firms, including new entrants, are going to have the same costs, which leads us to have a perfectly elastic long run market supply curve because we're always going to end up back at that price, the only price that can give us a zero profit long run equilibrium, assuming all firms are the same. So there's another possibility where we have an increasing cost industry. So for the AP exam, you do have to know what this is, although they wouldn't expect you to draw it because it's a little more complicated, but I will show you what it looks like. So we're going to have, and what we mean by increased cost essentially is that as this industry gets bigger, it's going to drive up costs in this industry as opposed to keeping costs the same. So imagine there's some relatively scarce input that's going into this production process. Let's say it's a rare metal or something. And if we get bigger and more firms produce, it's going to drive up the cost of that input. So every firm is going to see higher costs. So we're still assuming that all firms are identical. But if the industry gets bigger and we have more firms, it's going to start pushing up costs. So we're going to see cost curves increase in this case. So something causes demand to increase in this market, whatever good we're producing, and that drives up the price. The difference is here, because of the higher quantity in this industry, we're producing more, and that is now going to shift up our cost curves. So our original cost curves were here in blue, and now we're going to assume all firms are going to experience higher marginal costs, which shifts up marginal costs, and it's also going to shift up average total cost. And let's assume every firm now has these higher cost curves instead of those original cost curves. So the price is still going to be up here. That is our short run price that we're assuming is happening here. And so we can make profits in the short run. And so these firms are going to set price equal to marginal cost, choose your profit maximizing quantity. We're going to have a profit here. The difference is we're not going to be able to go back to long run equilibrium assuming our costs are here now, because at P1 we have losses, firms are going to exit, it's no longer a long run equilibrium if these are our new costs. So as long as costs, even if we contract a little bit, as long as costs stay above that original level, then this has to be our new long run equilibrium. So we're not going to go back to P1. We're going to go back to some price in between the original price and where we were in the short run. In particular, we have to go here so that we have a new zero profit equilibrium. So we're still going to have firms entering. So we're here in the short run. Now firms are going to enter, supply shift. If it was constant cost, we'd go all the way down to here because that would be our zero profit. But since we're only going part of the way, we end up here. And so instead of having a perfectly elastic long run market supply curve, we're now going to have an upward sloping long run market supply curve. And I'm not going to show you the case of a demand decrease, but you can go through that. You would just have to end up going down here instead of our constant cost case where we stayed at P1. If our costs are falling, it would just be the opposite. We would have to be at a long run equilibrium below that price. But so you can see that the long run curve is going to have to be flatter than that short run curve, because assuming we have entry, we're going to have some profits, something caused the price to go up, we're going to have some profits in the short run, but also higher costs. And as long as we have some entry, we're going to have to end up lower than that in the long run, but still upward sloping. So we can no longer get back to that original price because we have to keep firms at zero profit, or else it's not going to be a long run equilibrium. If we went too far, firms are going to exit, we're going to go back here. So that's the increasing cost case. So you basically just have to know the intuition of what it means to be increasing cost as opposed to constant cost. Let me just mention one other possibility. So we might relax the assumption of having all identical firms, so that suppose we had the example of, say, the oil industry or gold mining or something like that, where if demand increased and we increase output in the industry and new firms come in, it could be that only the new firms have higher costs, and we might stay, some firms or maybe one firm stays at this lower at these lower cost curves because maybe you're drilling in a low cost place where new firms have to drill in or mine, depending on the case, in a higher cost place. So we would have to relax that assumption of identical firms, but otherwise it would be similar to the perfect competition case. So this is the only case where you might have long run profits for at least some firms, because now what would happen is the new equilibrium would just have to keep the marginal firm or the highest cost firm at zero profit. So if let's say every firm except for one or maybe a few have these higher cost curves and some other firms are able to produce at a lower cost, well, in order for there to be long run equilibrium, we're going to have to keep that marginal firm at zero profit. But in that case, at P3, these original firms in blue, they can make a profit. So by relaxing that assumption of all firms being identical, we could have a case where one or some firms are making a profit if they have different cost curves. So you don't see that too often. I remember there was a textbook question, I think in ManQ, that talked about the gold mining industry and used that as an example. But again, you just need to understand the intuition of what's going on with an increasing cost industry where costs are rising if it expands, or costs are falling if it contracts. A couple of things that I want to revisit now that we know a little bit more. We can go back to supply and demand and we can answer the question, what is the relationship between producer surplus that we had when we were doing just normal supply and demand curves and profit? So they're not the same thing. What's the relationship between those two? So a couple of simple equations can help us out here. So now remember that this supply curve is, if it's a market supply curve, it's the sum of our firm short run supply curves. Remember, that's marginal cost. They're marginal cost curves. It's part of the firm's marginal cost, but they're marginal cost curves. It's telling you what is the extra cost of producing one more unit, and that's why firms are willing to produce one more when the price increases. So now, if this is, remember, marginal cost is variable cost. It's the cost that's changing when you produce more output. So each quantity here, each unit of quantity is telling you what is the variable cost at that particular unit, and so the sum of all that is the total variable cost. Right? I'm just summing up the marginal cost or the variable cost at each unit, and so what that area represents is the variable cost if I'm producing all of these Q1 units, since this is a marginal cost curve. By the way, demand is also a marginal benefit curve because it's willingness to pay, so it's how much extra benefit someone's getting from each particular unit. That'll be important a little bit later on. So now we have producer surplus, variable cost, and remember what this whole area is total revenue. Right? This is just price times quantity. So take this whole area, total revenue. If you subtract out the producer surplus, we're left with variable cost. So just rearrange that. If we subtract variable cost from total revenue, we have producer surplus. Remember, our profit equation is just total revenue minus total cost, and I just broke it out into variable and fixed. And so now I'm just going to substitute, since we know now that total revenue minus variable cost is the same as producer surplus, that gives us the relationship. Right? So profit is just producer surplus after you take out fixed costs. So in other words, this is the gain to producers once I take out my variable cost, but I haven't taken out my fixed cost yet. Right? This isn't showing me fixed cost. So once I take out the fixed cost, then I'm left with profit. Or in other words, if I rearrange that, producer surplus is profit plus the fixed cost. Because again, I'm only subtracting the variable cost from here. Just a little aside, if you know some calculus, this is a nice application of the fundamental theorem of calculus. So we have marginal cost here, the rate of change in cost with respect to quantity. And what we're doing is summing up these little rectangles where we have the change in quantity times the rate of change in the cost. And so as we accumulate that, we are summing up to get variable cost, or in other words, if we take the antiderivative of marginal cost, we get variable cost, so we get the area under that curve. So just a little fun fact, Let's move on. Okay, one other thing we can now revisit and add one more thing to our cost curves. Now, if we are perfectly competitive, which remember means that I'm a price taker and I'm selling if I produce more output, I'm selling it for the same price. And so if I create a total revenue curve here, this should say cost and revenue so that I'm labeling both. Total revenue curve would just be a straight line like this because it would just be the price times the quantity. And so if the price is not changing, so this is only true for a perfectly competitive firm because as you produce more output, the price isn't changing, right? Remember, I'm facing that perfectly elastic demand curve, so I can sell another unit without having to drop the price. So it would just be price times quantity would just give me this line. So if it was price of 2 would be 2q would be that line, since this is like x, the x variable. So if the price changed, this would kind of rotate around to give me this total revenue line. And then if I was profit maximizing, I would just want to have the maximum distance between total revenue and total cost, and so be right around there, just kind of eyeballing it. And it also, remember, marginal revenue equals marginal cost. Marginal revenue would be the slope of this curve, which would also be the price, because price equals marginal revenue. And so when that slope equals the slope of this curve, this would be marginal cost, right? I want to set marginal revenue to marginal cost. So right around there, when those are equal, would also give you the biggest distance in terms of the totals. So that would be your profit maximizing quantity. So just keep in mind, as soon as we have a case where we're facing a downward sloping demand curve, unlike a perfectly competitive firm, then we're going to have to go back to where our total revenue curve was kind of shaped like that, where it rises and then falls. We'll see that when we do monopoly and our other firm types.